Ladies and gentlemen, welcome back to the Rare PETRO podcast media team. Because of you and your continued support, we actually have a new segment, the Modern Mobile Oilfield. For the rest of the series, I will be joined by digital oilfield specialist and tech guru, Jeffrey Can. Welcome to the show, Jeffrey.
Thanks so much for inviting me to participate in this.
Of course. How are things in Canada? How are you doing?
The weather is good. The pandemic is bad. So situation normal for summer.
Same thing here, minus the weather. We're seeing a few wildfires, but hopefully we're working through the worst of that. We are excited to bring you this series as it serves as a companion to the Bible of oil and gas tech. Bits, Bytes, and Barrels by, well, Jeffrey Can. Can you give the people a quick overview of what they can expect to find in the book?
Sure. The book was written with the intent to introduce the various concepts associated with this wave of digital change into the and share how they will impact the oil and gas industry. So it's been described as the go-to book for anyone wishing to understand how to transform oil and gas using digital. And for younger audiences, so young professionals in the industry, the content will feel very familiar because it plays directly off of the social life that we all lead. But for those who are experiencing the industry, it's a real eye-opener around how digital will affect the industry.
Perfect. And like I said, this podcast will serve to be a companion to the book as we expand on the technologies discussed in a 9-episode series, Everything Willing. And actually, let me get a little POV shot so you can actually see page 30. This is what we'll be talking about. Here we've got, phone up, high production quality here in the studio. We've got this graph, technology maturity on the x-axis, impact on the industry on the y, and we will be starting in this corner and working our way back to the origin. So, as you can see, top right, today we have cloud computing. That's what today's episode will kick off with. So, everyone has a general idea of what cloud computing is. You know, data goes up into the cloud, stored in the cloud, but can you give us a quick overview and explain the advantages, disadvantages, and uses within oil and gas?
Oh, for sure. So cloud computing, we're all very familiar with it, even if we might not personally directly work in the industry that provides cloud computing. But if you interact with Uber or Airbnb or Netflix or Amazon, you're engaging with a computer system that is actually resident in a what's called the cloud infrastructure. So cloud, the way to think about it is imagine banks and banks and banks of computer servers that are connected to the internet, providing everything from computer horsepower on demand for complex calculations, as well as storage of vast quantities of data. Those are the advantages of cloud: unlimited, on-demand analytic horsepower for calculations, and storing these enormous data sets. The advantage is that organizations do not need to stand up their own computer infrastructure, and they don't need to constantly invest to keep that infrastructure up to speed and modernized, because the cloud companies take care of that. And thirdly, when there is an urgent and immediate need to stand up some infrastructure to address some urgent either opportunity or an incident, it's far faster to stand up that infrastructure by provisioning it on the cloud than it is to order technology from a hardware supplier, because that often takes months before it shows up. The downside, though, is that once your infrastructure is migrated to the cloud, it's very, very challenging to see how you'll get it off the cloud. So once you've got petabytes and petabytes of data stored there, moving it around becomes more of a challenge. But the advantages in general outweigh the disadvantages. It's far cheaper, it's more secure, and it's available on tap.
Of course. I'm glad you mentioned just how common it is, too, because my sister owes a lot of thanks to cloud computing because she's not dependent on Netflix, but it's definitely integrated into her life. So, all software, of course, isn't created equally in terms of quality or even just application. There are different services afforded by cloud computing, such as infrastructure as a service, platform as a service, and software as a service. What are the differences between these services? What does that exactly mean? It sounds like a whole lot of mumbo jumbo up front, but how does it apply?
Well, infrastructure in this case means computer infrastructure, so servers, telecommunications support, data centers. So the way to think about infrastructure as a service is you simply go and you purchase that as a service available to you. This is not that different from the outsourcing models of the past, except that the infrastructure itself, cloud infrastructure, is shared with many different organizations at the same time. Platform as a service, though, is where you may wish to engage with a computer offering on which you in turn create your business model. An example of this might be, say, Airbnb. Airbnb offers a platform where us as individuals can go and say rent a unit, a house for the weekend. But you could also build an entire business where Airbnb is actually servicing as your platform and potentially white labeled. This is as your service. I personally do this with my own service infrastructure where I run training courses. It looks like I'm running them on my website, but in fact, I'm using a platform that's available on the cloud. And third, software as a service is where I simply take an existing application I might have running, say, was on my own data center, and now I put it onto the cloud and run it in the cloud. This is a fantastic way to lower cost and improve performance, and particularly where that software may require special capabilities or services to keep it up to date and running effectively at scale. So 3 different models, and very, very common. Most organizations, when you get into the cloud world, will find themselves dealing with all 3 models at the same time.
I'm just going to take a stab in the dark, though, from what you've explained. Is oil and gas going to mostly make use of infrastructure as a service, or is it pretty equally spread among the 3?
So far what I've seen is it starts with infrastructure as a service, as just a straight cost reduction play. And you'll see a number of large oil and gas companies as a first move, shifting their infrastructure out to cloud service companies. So it starts there. The software companies, though, who offer their technology principally driven against the assumption that the buyer would have their own data center, are suddenly finding themselves needing to convert their technology so that it will run on the cloud. And so the third platform, even though we present it as infrastructure platform software, software is generally number 2 as opposed to platform. Platform, the third one, is much trickier because to get to platform requires more sophistication on the part of both the buyer, who's willing to purchase the services, as well as the seller, who is putting their business on somebody else's structural platform. And the industry is not quite there yet in using that as a widespread element of its operating model.
All right, so like ants to honey, they find the infrastructure services and they're just dumping mass amounts of data, and then their eyes are opened and they kind of see what else they can afford them, and then they're in too deep.
That's it. And
All
of course,
right.
the service companies that sell software, if you're a technology company and your offering is software, you discover very, very quickly that once your customer base moves to the cloud, they expect you to move too. And so software moves quite quickly into the cloud infrastructure. It's also cheaper if you're a technology company to put your technology into the cloud because you don't have to support 5 different underlying technology platforms, Unix and IBM Plant and SQL. You just put it on one database and then you offer it as a cloud service. It's a lower cost option as a technology company.
Alrighty, so lots of good technology options, but none of these solutions are free from problems and setbacks, I would imagine. Nothing is ever as nice as it sounds. So, when organizing the setup of a cloud computing service, what architectural questions do you have to consider? I mean, it's easy to think that it's 100% out of your hands as soon as you select Amazon's services, but I'd bet that's not the case at all.
No, that's true. It's not the case. There's many architectural questions that you get into, but I'll just give you a couple to think about. Legally, on some jurisdictions, some kinds of data can't leave certain geographical boundaries by law. And so if your architecture is set up to leverage cloud infrastructure, you may need to be mindful of the fact that legally, you may not be able to put your data into the cloud, particularly if it's going to leave your country, your province, or your state, if the rules are set up such that that's not a permitted thing to do. So architecturally, you have to plan and think about that. Other architectural questions that arise relate to the kind of compute bandwidth that you need. For instance, if your business model is to, say, provide data in a complex visualization data delivered down to individuals in, say, their home setting, as we all find ourselves in the pandemic, that may require bandwidth and telecommunications support, which is in excess of what you might normally do if that infrastructure was just resident in an office. And so partnering up with a cloud company that can assure the delivery of that quantity of data the way that you're after is also quite useful, a consideration around architecture. And then there's all kinds of other elements, cybersecurity, which I think we'll discuss in a bit, how you get support. All of these questions come into the frame around cloud strategies.
And then the data, geographical boundaries, I'd never heard of that. Is that something that's pretty heavily regulated, or are there a lot of loopholes with, say, a VPN accessing the cloud from outside of the boundaries but remotely, virtually inside, or is it not as muddled as I might think?
No, it is as muddled as you might think. It is not. It is not clear cut, and because governments can change the rules at a moment's notice, the requirements, you have to invest quite a bit of energy to stay on top of these requirements. As an example, some kinds of customer data, health data would be another good example. Customer data, financial data, but in the oil and gas industry, subsurface and geologic information. Particularly for those countries where the main value of that nation is tied very much to how much oil it produces and its the characteristics of its reservoir. The governments may be very clear and say that data cannot leave our country,
Wow.
and for very good reasons. You have to stay on top of the rules so that you know what you're allowed to ship out of country and what you're not allowed to ship out of country.
Mm-hmm. Well, cloud computing, it's nothing new, and it's probably so common I see it as a buzzword at this point. A lot of people have taken advantage of it. What about oil and gas? I mean, I know Hess made that jump pretty recently to shift much of their work to the cloud, but it seems that change, as we talk about time and time again, rolls pretty slowly when it comes to these major and mid-cap companies.
When I was doing the research for my book, I came head to head with this attitude about the industry and the cloud computing industry and its ability to service the needs of the oil and gas sector. But in 2017, one of the super majors in Europe ran a trial, if you like, to test the capabilities of cloud computing in 2017. So this is 3 years ago now. The test they ran was to dump a bunch of their subsurface data into various cloud companies, and then have the cloud companies try to process that data. If you go back in time, oil and gas companies, particularly the super majors, were the biggest buyers of supercomputers in the world, because you needed the supercomputers to do the computations, to do the modeling. What this super major discovered was that the cloud computing companies, far back as 3 years ago, were able to match the ability of their internal supercomputer data centers to be able to process the same data. That's when the light switch went on 3 years ago, that the era of oil and gas companies feeling like they needed to own and manage their own compute infrastructure for such delicate tasks as subsurface data processing was no longer a viable strategy. And that's what's unlocked the migration to the cloud. It is well underway. Many super majors are moving to move their data and infrastructure to the cloud. There's still lots of barriers and roadblocks, and there's still a very, very long way to go. So we're just at the very early stages of this wave. But there's no question it would appear to be unstoppable at this point.
Unstoppable. Love to hear that. And then was that shift mainly a function of price, or was it just convenience and the space it afforded if they didn't have all of this data processing stuff on their facilities?
Well, in 2017, it was absolutely a question of capability, not price. Because prior to that point, the amount of money that oil and gas companies were prepared to invest to do subsurface data processing was very, very substantial. And the reason for that, of course, is oil and gas is so valuable. So the gap between how much you're going to pay to process it versus the value of the resource if you do process it was so great that it just made no sense to even worry about owning your own infrastructure. However, by 2017, it became clear that not only could you get the computational horsepower you needed on tap in the cloud, but you could do it at a dramatically lower price point and at higher levels of security. So at that point, the equation tipped over and it became very compelling to shift. Now it's a money question. It's not, it used to be capability, now is money. It is so much cheaper to do things in the cloud that it makes no sense, literally, these days, to continue to hold on to a supercomputer-based or heavy-duty infrastructure inside an oil company. It's very clearly time now to move everything to the cloud.
Yeah, and you kind of mentioned that in the earlier chapters of your book. Is it Moore's Law, if I'm not mistaken, where things are going to get, well, much more efficient and eventually cheaper technology-wise, to where it's going to become a standard? Like you say, it's unstoppable.
It's unstoppable. Yeah, there are two laws that I sketch out in the book. One I name quite explicitly, the other I do not. But the first law, as you touch on, is Moore's law, named after Gordon Moore, who identified the phenomenon that over time some things demonstrate an exponential rate of change, and that could be capability going up or costs coming down or a combination of the two. He noted it in the density of transistors on a circuit board. We're all very familiar with Moore's law now because we see it in viral growth rates, right? The pandemic is growing virally. We call it viral growth, but in fact, it's following Moore's law.
Mhm.
If you do the math in Moore's law, it's actually a 40% compounded annual growth rate.
Okay.
That's what it equates to mathematically. Now, most businesses, if you are doing compounded annual growth rate of 5%, you're feeling pretty darn good. But 40%.
40%. That's something, that's not anything to sneeze at. That's significant.
It is. The second law is Robert Metcalfe's law. So Robert Metcalfe was a researcher at the time when Margaret Thatcher was deregulating the British telecommunications industry. And his question was, what is the value of a network? And he identified that the equation is n squared, where n is the number of nodes on the network.
Mhm.
Now, what that means is that if you have a network and you connect up multiple participants in that network, the bigger the network is, the greater the value by a factor of n squared.
Mhm.
Now, what does this mean for oil and gas? It means that as the drive to build networks, that can be cloud computing, computers in the cloud, or the internet connectivity between businesses to enable things like new business models. That Moore's law and Metcalfe's law combined are what create this hyper growth rate in the digital world. Oil and gas has never really taken advantage of these two laws because we're driven much more by physics and chemistry, steel and cement. But digital builds on these laws. And so the shift in oil and gas is to figure out how do we change the business model so that it can harness the economic impact of Moore and Metcalfe, M&M, if you like.
All right. I want to pitch a hypothetical to you then using those laws. I mean, as things become exponentially cheaper and exponentially more effective at processing data, and companies are working just to add more and more nodes to their network to make it that much better, what is the ideal future for oil and gas? Is it a big international database, or probably not so much because those NOCs, like you mentioned, would that be a national security risk? Where does it go?
Well, I don't think the future has been really laid out in a nice, neat, orderly pattern for us to
Uh-huh.
follow. So I honestly don't know what it's going to look like. But there are a few trend lines that look very, very crisp to me. One is that the oil and gas industry will ever more embrace cloud computing and move more and more of its compute needs and infrastructure data into the cloud. That trend line looks unstoppable. That then in turn unlocks new business models, but we don't know yet what those new business models might actually look like.
Mm-hmm.
There's some hints. As an example, and this relates to the adoption of blockchain technology in the automotive industry. So you might say, well, what's that got to do with oil and gas? Well, oil and gas sells gasoline into the automotive industry.
Yeah.
We're big sellers of product into transportation. If we connect up cars on using blockchain to create trusted autonomous actors in a transportation network, we fundamentally change how much gasoline we consume.
Mm-hmm.
There are studies that show that if you were able to displace all taxis in New York with a fleet of robotic, autonomous Uber vehicles driving by themselves, all of the transportation requirement for all of New York City could be met with just 8,000 cars.
For all of New York City.
For all of New York City. So if you take that mathematics and you extend it out, you can see that if we move from a current world in New York City where there are hundreds of thousands of cars to one where 8,000 satisfy all demand for all transportation, then you very quickly get to a point where, well, the demand for oil and gas is going to decline, and because we won't need that kind of transportation plan.
Mm-hmm.
And how do you enable that? Well, you'd have to have some way to connect up all of these vehicles and deliver that transportation service. How are you going to do that without things like cloud computing to allow you to do things like transact and bill and track vehicles and so forth? It's not conceivable that you could do it under our current infrastructure play.
So, from what we've seen so far, clearly extends to other sectors such as transportation, like you mentioned. But in terms of oil and gas specifically, it seems right now it may be better suited for upstream. Can we expect it to expand to retail and transportation soon, or will most of the data and use remain centered around production and exploration?
It kind of depends, and I know that's not a very satisfactory answer, but it does depend. As an example, because cloud costs have fallen so low, it's economically now quite compelling, regardless of where you're at in the industry, whether you're midstream or downstream or a pipeline or a refinery. Kind of doesn't matter. You can move your infrastructure to the cloud.
Hmm.
And so cost is going to be the driver as opposed to, does it make more industrial sense to be on the cloud one way or the other? Cost kind of takes care of that equation. As an example, even in the refinery context, there's a specific function that refineries go through called using what they call the linear program. It is the LP is the mathematical model that defines how to run your refinery to maximize the outcome you're after, which could be margin or meeting a product demand or what have you. And in the current world, I can only run my LP once because I'm doing it on my own compute infrastructure at my refinery. But in a cloud world, you could actually run that LP dozens and dozens of times simultaneously. And that changes fundamentally how many scenarios you can play with on how to run your refinery, even down to where you could run the LP on a cargo by cargo basis or barrel by barrel basis. This changes how you think about refinery economics, literally overnight.
Yeah.
That means that refineries, even though you'd say, well, why would a refinery be on the cloud computing? That alone could be reason enough for the refineries to start to shift over to cloud, let
Hmm.
alone cost.
Oh, of
So
course.
this is not really an upstream story or a downstream story or midstream story. It is an industrial story.
It's just a matter of time and to how
Yeah.
far it spreads. All right. And then you said changing overnight, and I kind of want to touch on that in the context of current events. So, like you said, I love your analogy of some people, they are hedgehogs, where as soon as they are projected to any sense of change, they curl up in a ball and fight it and avoid it. But has the time frame for cybersecurity, data, cloud computing, all of these things, has it changed as a result of COVID-19? I imagine it likely accelerated transitions or forced people to consider cloud computing as a solution in this work from home remote access era. Is this true?
Um, I'm not sure I would characterize the pathway as that linear.
Mm-hmm.
In other words, my employees, to work from home, they have to have cloud computing. It doesn't quite work that way because you can enable your employees to get access to your corporate infrastructure and your computer systems through gateways without actually having your backend in the cloud. So the reality of the pandemic is the pandemic doesn't drive cloud computing. What drives cloud computing is new business models and lower cost, greater capability, improved cybersecurity, better performance, faster capital execution, a whole bunch of other drivers, not just in the pandemic. I don't think there are very many oil companies who have started I might be wrong because I haven't heard of any, but it does not strikes me as because you have a pandemic, that's what drives you to push your infrastructure to the cloud. It's not quite that linear.
Mm-hmm.
Now, that does not mean that some companies will look at their existing back-end infrastructure and realize, holy cow, we can't deliver our business because we are structurally set up as if everybody's working in an office. And no amount of finessing is going to fix that. Those companies may then embark on a cloud strategy because it will fix that sort of structural problem that they've got. But for the most part, I would say the pandemic does not linearly compel you
Mm-hmm.
to go to cloud computing.
I guess that's just me wishing for a perfect world, huh?
Well, your perfect world is the cost and performance curve have shifted fundamentally, the economic calculation. And so your perfect world's already here. The pandemic is helping move it along, but it
Mm-hmm.
is not the driver.
All right. Well, let's say we'll take it outside the context of a perfect world, but I am a new exploration and production company, refining company, midstream, whatever, stuck in my old fashioned ways, looking to keep up with the rest of the competition. If I'm looking to pursue cloud computing, where would be a good place to start my transition as an executive? Let's assume I'm technically very literate, very literate. It implies improvements in considering data, cyber aspects, recruited talent, and agility in navigating and processing this tech, but where can it first be planted? I mean, that's a lot of stuff to consider.
It is, and where I would advise organizations to start is to go and visit some peer companies to see what they've targeted and tackled, because there's no real good logic that says you need to kind of discover all of this on your own. So I would start with, where's the peer group gone and what have they done? What have they done first as a driver? What you'll typically see is that the first question you have to address is, if you move your data to the cloud, not necessarily all the computing that you'd want to do, but just the data itself. Most organizations have a lot of what I call rot data. So it's redundant, it's obsolete, or it's trivial. Why would you move rotten data to the cloud? What would be the point? So a step ahead of that is to stare hard at the data holdings and then just ask the question, where is it most important that we gain some sort of advantage because of the cloud by moving our data there? And that may mean having a rot strategy. How do I deal with that redundant, obsolete, and trivial data? How do I get rid of that as a first step? That may drive you to say, well, in order to get to that, I need to actually have a data strategy. So I might start with having some advisors support me, or my computer team, my IT team, and my OT team. Help me understand where the data that has the greatest value, where does that data reside, and it's that data that I then target as the first step in my cloud program, that I move that to the cloud.
All right. So back to the hypothetical. I've stripped all the rotten data. I found a great way to sort through it and organize it on a cloud computing system. What about the rest of my team? How can I get them accustomed in terms of changing workflows and traditional processes? Is there going to be a lot of new training, or is it similar to some of the transitions we've seen in the past and maybe a lot smoother than someone would imagine?
The talent strategy is actually one of the hardest part of the puzzle pieces here to put into place. And the reason for that is that the educational institutions who are churning out the graduates that have the expertise that the oil industry needs have not yet reconfigured their curriculum to generate the capability that the industry needs in the volume that it needs, and in the locations where it's needed, where those individuals are able to bring to bear both the industrial know-how they've learned, that is how the oil and gas industry world works, and the digital world and how that works. Generally, those are two solitudes. So I go to my petroleum engineering school, and I go to my computer science school, and they're not merged and blended together yet. What this really means is that if you wish to embark on the adoption of many of these digital tools, you're going to have to figure out, how do I blend those two together? And that may mean going to an industry that's well ahead of oil and gas, like financial services or telecommunications or entertainment, and getting those individuals as that background, who don't understand oil and gas, by the way, but they may understand data science and data management and digital. And then you marry those up with your domain experts, and you create that collaborative relationship where those folks work together to tackle the challenges associated with digital adoption.
Yeah.
That's the pathway that I see industry is going to have to go down, simply because there is a huge shortage of people who understand this, who are already inside the petroleum industry.
Oh, I'd have to agree with you. I mean, I just graduated myself, and a lot of the work, data reduction, we did with Excel spreadsheets. I imagine
Yeah.
we're reaching a point where that's not going to cut it anymore. So we have to marry, like you said, the technical context with the know-how to process that data, and those teams are going to be the most effective.
Exactly right.
Do you see someone in the future, maybe petroleum programs adjusting to match that goal, or maybe just data science reaching a point where they'll train contextually so they can go into an industry, making maybe an engineer obsolete?
Yeah, very good question. I don't know how the
Hmm.
educational institutions will play this out. But I can imagine the conversation internally in an educational institution, where you say to the petroleum engineering school, which is already a jam-packed four-year program, which is hugely challenging for anyone to do, saying to the leaders and owners of that curriculum, you're going to have to you have to make room for new content. What are they going to jettison? And say, well, we're not going to do that anymore.
It's tough to pick and choose there.
Very, very challenging to pick and choose. And so I think the curriculums are going to have to reconfigure to create space for these courses so that the students can learn how to take advantage of these tools and marry them up with the domain knowledge. There's also the potential for the courses themselves. So imagine you're doing a reservoir modeling course. It's already very technical, but the instructor may be asked to inject digital concepts and thinking into that curriculum. Well, that requires the course instructor to become digitally smart ahead of that. That's a track that also needs to be laid out so that we can achieve that. Once you start to think about it in these sort of sweeping terms, there's great compelling industrial logic here, but the actual execution of it is going to take a great deal of time.
No, of course. The future of cloud storage and mass data computing is going to be beautiful. It's just a matter of getting everyone there.
When
But
it gets there.
back to my hypothetical. I'd like to talk security. I mean, I know a lot of this data, as you mentioned, can be very sensitive and even a question of national security for some people. Will cybersecurity afforded by cloud computing be greater or less than the quality that a company making the transition may already be accustomed to?
In the main, the cloud computing companies are more secure than individual companies in the main. Now, it's not exclusively, it's not 100% accurate to say that all the time, because there are lots of examples of cloud companies and cloud services that have been penetrated by hackers. But once certain kinds of vulnerabilities are detected within one cloud company, it's very, very quick for that information to make its way around to all of the other cloud service companies to patch the problem area up. And because of the business model is so dependent on reliable services and reliable support, the cloud companies are highly motivated to stay on top of the patch requirements. It is, and so as a result, they are superior in that regard. Whereas the individual company might have just 10 IT professionals supporting all of the computer infrastructure, and maybe there's a part-time cyber professional. It's very easy to see how that company might be unable to keep pace with the amount of cyber activity that's going on out there. So from my vantage point, I would place a higher level of confidence in the cloud computing companies to provide the adequate cyber support that I need for my company.
All right, but corporate governance, I've adopted it. I feel safe. I feel secure. I'm using it. Things are going great. But like those laws you mentioned, technology will only get cheaper and more effective. How can it be assured that the importance of this tech officer's decisions are not overlooked as the cost of the service is reduced? Does this catch a bad rap for its comparatively low cost in the cash flow sheet?
Well, what you're touching on, though, is a really important question around technology governance in organizations. And this is actually not limited or restricted to cloud, to be honest. It's actually a far larger question around governance. But in general, the leading organizations take a much more broader view of governance over its investments in technology and infrastructure. And that includes investments in digital. As one of my clients used to say, a problem shared is a problem solved. And so a governance structure where you take a specific problem, such as how do I maintain pace with technical advancement, you engage more broadly in your organization to talk through what has to happen. It means you surface answers better and faster and with greater agility than those organizations that lack that governance and just leave it in the hands of one or two individuals. So good governance structures are really important in this new digital world.
And then we've got a whole lot of energy professionals and students that do listen to this podcast who may want to better position themselves to understand these technologies. I mean, outside of buying this book, of course, should they pursue specialization or just a general understanding of what cloud computing can enable? What risks should they be aware of?
Well, to learn more about it, all of the cloud companies offer some variation of training and awareness building for what their offerings can actually do. They're highly motivated to attract talent to support cloud infrastructure because that creates the demand for cloud infrastructure. One of the blocks that prevents many organizations from advancing with cloud is that because they can't find the talent that knows how that infrastructure actually works. So the cloud companies are working to solve that by creating the training programs and the curriculum and the awareness building. So the fastest way to get up to speed on this for career protection, and certainly the least expensive way, is to go on to the cloud service companies' websites and their offerings and take the, generally speaking, low cost or free awareness programs that they offer, so that you can start to internalize how that technology works, how it affects your industry or your part of the industry, given that our listeners may be on upstream, midstream, or downstream, is far more nuanced. Because, as I say, in the upstream, it may be about subsurface data management, whereas in the downstream, it might be about convenience store automation. So in that case, you have to be more surgical around where you learn about how cloud impacts your industry. But it would start with the basics, like which you can get from most cloud companies.
All right, that's some great advice, and probably advice I'll be taking advantage of myself, because I was not familiar with that before. But I think that hit all the points that I wanted to bring up about cloud computing. I mean, you as the expert, is there anything else you'd like to highlight?
I really would just underscore a couple of what I would describe as critical observations about cloud. There's no U-turn ahead. This is not a question of taking a risk that somehow, if I embrace cloud, I've created a risk for myself. There's a far bigger risk by not embracing cloud. So there's the first point. There's no U-turn ahead. Standing pat is not a good strategy. On the other side, though, the upside, which we haven't talked about as much, but what gains do you get from it besides from cost reduction and so forth? It's the enablement of new business models, which is the big prize here. And so for young people who are listening, as well as industry executives who are tuned into this, that to my mind is the biggest prize as well as the biggest risk. And much of it is going to be enabled by cloud computing.
All right, well, I think that concludes the first episode of the Modern Mobile Oilfield then. You can follow the development on this podcast by following both Rare Petro and Jeffrey Can on LinkedIn. And in addition, you can find this podcast between SoundCloud, Apple Podcasts, Spotify, but I'm sure you're already listening on one of those platforms, so I'll let you keep at it. Finally, I cannot recommend this book enough. I mean, sure, I had to read it to be able to be literate for these interviews, but it is fantastic. We do get into some nitty-gritty details on the podcast, but there is a great broad understanding in bits, bytes, and barrels. This podcast makes a good companion, but it will never replace the book. Jeffrey, where can our listeners find themselves a copy?
It's available on many online bookstores. At least 100 online resellers carry the book. It is print on demand, which is a digital innovation, as it turns out, which was very appealing to me since when I was putting the book together. But it's print on demand, which means you can't buy it in a bookstore. You really only can order it online. And once you place your order, it gets printed. There's no inventory anywhere in the system for the book. So that's how you get it. You go into Amazon or some your favorite online bookseller, wherever you are in the world. There's also an audio version of it on Audible and Amazon and iTunes. And there's a soft copy of it on a whole other range of platforms if you want to use a Kindle reader or some other way to get access to the book. So there's lots of ways. It's not very expensive. It's the e-version is $10. So if you can't spend $10, the price of 2 cups of coffee, you can see how a $1 trillion industry is about to be impacted by digital. It's money well spent.
Oh, of course. So that wraps up the podcast, everybody. Like he mentioned, let's prevent ourselves from becoming obsolete. Let's stay with the movement because it's only a matter of time and keep learning together. So until we see you next time, first of all, thank you for joining us, Jeffrey, and everybody, take care.
Bye for now.